Hello. Could somebody on the stream just confirm you could hear me? That would be amazing. Thank you. Okay. Hello, everyone. If you haven't taken a seat yet, please make your way through quietly. We're going to get going in just a second, and I'll hand over to Moritz, who's our first speaker. Before I do, just a couple of quick announcements. So the first one, before I forget the date, the next one of these is on the 19th of July. So I'm running them every 2 months at the moment, which seems like a reasonable cadence. I've got the date already locked in this time, which people always ask me. They say, when's the next one? And I can't quite tell them. This time I've managed to sort it out in advance. So yeah, 19th of July will be the next one. And just confirming the speakers, and then that will go out on Meetup as well. Thank you all for coming today. It's great to see loads of people in the room again. Hopefully some people joining us online. It's very informal, right? So chat to people, make friends, and sneak out and grab another beer if you need one during the talk if it's going on too long. There's no pressure to treat this like a boring conference or something. A couple of things then. So firstly, I would be rude of me not to thank my company that employ me and also help sponsor this event. So that's Selden. What we do is model management, deployment, monitoring, and explainability. So if you're interested in any of that stuff, come find me, or there are a couple of my colleagues wandering around too. We're also hiring like everyone else. So if you're interested in working in the MLOps tooling space, give me a shout. And then from that, I think that's more or less it, right? The loser at the back behind that kind of hidden gray door, because people always ask that one too. And with that, what I will do is I will pass to Moritz Meister from Hopsworks, who is going to talk to us about feature stores and reverse ETL processes. So I will take it away. I'm just going to unmute your mic one sec. You are...
Yeah, thanks for having us here in London. Today I want to talk about how to get fresh features, so updating features for machine learning applications at a high cadence and serve them to your serving applications with a feature store. We came from Stockholm today. We have a few people here in London as well, but it's very nice to come to London. What is Hopsworks? We're a platform which wants to foster ML collaboration, and we're doing that with a Python-centric enterprise feature store. And I'll get more into detail what we mean by Python-centric exactly. So we want to talk about reverse ETL pipelines. So let's go back a bit in time and look at what's ETL and the data warehouse has brought us. So back in the day, you had a bunch of operational services or applications, frontline support, Salesforce for marketing, or your shop system like Shopify, Zendesk for support. But these were data silos, right? So in the best case, they were talking to each other, at least bilaterally. However, what we brought in was the data warehouse in order to get a 360 view on our business and break those data silos, collect all the data in the warehouse so that we can perform analysis and derive actions from that, right? So if we talk about reverse ETL, the question is, why would we move the data out of the warehouse again? So the problem is basically the data warehouse itself doesn't let you make actionable operational decisions. So we need to bring the data somehow back to operations and ultimately to the end user and to improve our product, right? So this is what we call reverse ETL. So you want to take the actionable data that you have derived in your intelligence or analytics applications and bring them back to the front line of your business so that you can improve the customer interaction or the product itself. But now the question is, where does machine learning actually fit into this picture, right? It's also a kind of analytics application, but it has very different requirements from the traditional BI applications that we've seen so far. And for that, we should understand, like, where does actually the value lie in machine learning applications. Some might call it AI. I will stick to machine learning. So if we look at the evolution, you have structured data in your data warehouse, maybe big data, some unstructured text data, for example. You generate reports, analytics for them, provide them to your business units, they take decisions. That's the easiest case. Then there's something we call artisanal ML or laptop ML. It's where a data scientist or analyst sits there, maybe use some advanced methods like some clustering method to find segments in your customer base, to address them with marketing actions and so on. Then the more advanced cases is the first one, batch ML, which is basically you want to predict or perform predictive forecasting based on historical data in a batch fashion. So it runs nightly, weekly, whatever. And then the more advanced case of that, you do that on historical data, but on events driven. So let's say your users in the checkout of your web shop, you want to make a prediction about creditworthiness. You can do that purely based on the historical data, so aggregations over the activity of your user or customer over the past. And that's the highest evolution level. You can also do that including data that's actually coming from the application itself. So, for example, what is the current shopping cart worth? That's what we call a feature that's actually coming from the context of the request itself. So you want to be able to integrate that in your prediction as well, right? So you have historical on one side, and then you have the real-time or the context data, so to say, that's coming from the application. So the question is now, where does machine learning fit into our previous picture, and how can we use it? And for that, we need to understand that the data warehouse itself doesn't help us in that case, because usually the data warehouse, it's more transactional data that you have in your warehouse, and not so much aggregated and not in the format as machine learning needs. It's mostly numerical features that you need for machine learning. So there's always another processing step involved, where you need to transform the data, aggregate it, so to engineer features. And then you might bring it back, you perform a prediction, and you might bring it back to your frontline business unit or business service. But that leads to a very scattered picture where you have a lot of pipelines serving different use cases, different business cases, essentially. And it doesn't really foster any reusability or also discoverability. So one business unit might not know about the machine learning applications that others have developed, and there might be synergies you're lacking on. And that doesn't even really cover yet the highest evolution of machine learning applications that I've shown before, which are like standalone machine learning servings or serving applications, which oftentimes are even like almost integrated into the product itself, right? So they're not necessarily talking to any of those business services that I've been mentioning before. But they might be embedded in your web shop. They might need to retrieve data for calculating predictions and so on. So jumping back to the picture, so we can do the lower half quite well, I think, nowadays. So you perform the predictions, and usually there's some kind of connectors for data storage where you put the predictions, and then business unit reads them up and performs actions on it. But the problem is mostly those upper cases where you actually need to make sure that the data is available at any point in time. And that's where we add the feature store to the picture, which is meant to be a centralized unit to store all features and data that is used to perform predictions, basically. So you have the additional step of transforming and engineering the features, but then the features itself are stored in the feature store along with the metadata, schemas, data types, how often are they being updated, what's the job that's updating them, maybe statistics, so to make them discoverable by other data scientists, for example, if you want to reuse a feature and train a new model, and so on. And then we have a serving application, might be batch or real-time online, that reads data from the feature store, loads a model, performs prediction, and then in the batch case, dumps the prediction somewhere from where your services read them up and use them in the customer engagement, basically. And then you have the real-time applications, which instead of reading large batches of data, processing them in regular intervals, it's doing on-demand lookups of feature vectors for entities in your feature store. So, for example, for a customer, performs the prediction and then uses it in the product. And what I'm hinting at here is that you have two very different use cases, which have not only different business requirements, but also very different technical requirements. So on the one hand, you have the batch cases, which are mostly volume of data. You care about versioning the data. So when was the feature updated? How did it change over time? You want to make sure it's accessible, right, in large batches. And you want to make sure it can be reused. So for example, what you often see is like, if you have a model, let's say churn, you might also have a customer lifetime value model, and the features are oftentimes overlapping in a large part. So you want to be able to reuse them, right? And then on the other hand, you have the online or the real-time features, and there you have actually really strict SLAs, and that's mostly for performing a lookup. So if you want a coherent user experience, right, there's this rule: if something takes longer than 500 milliseconds, half a second, you will notice, or the user will notice. So you have some requirements on like how long can it take to look up the data for this entity and perform the prediction. And usually, yeah, you have to be quite fast. And if you have large amounts of data, that gets harder and harder. But then it's not only the lookup, you also need to make sure that the data that's inside the storage and that you're looking up is actually fresh and being updated at a high cadence, right? Especially if you have, data sources which are based on events like click streams or logs, event logs, and so on. So you want to be able to update the features at a high cadence. So we care about feature freshness mostly. So how long does it take, for example, when an event gets written into Kafka to update the feature on the feature store? And that leads me to the infrastructure that you need to fulfill those requirements. And that's on the one hand, a block-like storage, a data lake, essentially. In our case, that's HopsFS, our file system that sits on top of S3 or Azure Data Lake or GCS. And then additionally, you have a low-late or an in-memory key value store that stores the features for real-time serving. So you want to be able to, based on a primary key, look up vectors of features quickly. And that's HopsDB in our case. And then comes the hard part. You need to make sure they're consistent, right? So when you draw, for example, training data from the offline storage, from the block storage, the way it's being computed you need to make sure that later on in production, the features that end up in the online feature store are computed in the same way. So you need to ensure consistency between the two. Yes. And then, yeah. So I already said it, but what's the performance we care about most? So on the one end, we care about latency, looking up the features from the online feature store, throughput, how many lookups can we perform if we have an application that needs a lot of vectors. And then for batch data, it's also the throughput. So we want to be able to query large volumes of data for computing batch predictions. And then obviously the whole feature store itself should be highly available, because you don't want your serving applications to starve because the enterprise or the feature store can't fulfill the requests to the online feature store. And then, as I said, we care about feature freshness and mostly about throughput. And a lot of people might ask, why do I need another storage apart from my data warehouse? Why can't I have all the features in the data warehouse? And the main reason is that you cannot fulfill all these things with your data warehouse. Feature store is a dual database system, so we need to have a bit more infrastructure than just the data warehouse itself. And just to make some examples, for example, why throughput for your input pipelines matters. Let's say you're a bank. So far, you've been only doing analytics on your own transactions, the transactions you know of. And then you add a new data source like open banking data, and suddenly the volume increases. So you need to be able to support those data sources. So you might want to switch from Pandas data frames to PySpark processing or Spark as a processing engine. And then freshness, we see a lot of like security applications where it's important to have really the view of the entity that you're performing a prediction on as close as possible to real time. So for example, if you perform network intrusion analytics, it's really important to see all the logs or all the packets, just the time frame just before the intrusion is usually the most important. So it's really important that your features get updated in a high cadence and very low latency as well as use cases. So now the hard part, how did we actually implement this and how does it work within Hopsworks? And so essentially machine learning, it's also a reverse ETL pipeline. We take data from the warehouse and we want to make it available in the feature store, right? You might have some pipelines that bypass the data warehouse, real-time applications that directly write to the online feature store. So the architecture is I would say, quite standard. What makes it unique is, I think, the metadata and the consistency, that makes it unique and provides the value. So on the first step, there's a client API, and we call it a data frame API. So all the data that goes into the feature store comes usually from a data frame that might be Pandas, Spark structured streaming, or regular Spark data frames. Recently, we've also been supporting Flink data streams. So there's a client API, you get a reference to a feature group in the feature store, and you insert a data frame to it. What's happening in the backend, what the user doesn't notice is data gets encoded, gets written to a Kafka cluster, and from there we have basically two pipelines. One is for the offline storage, which is a Hoodie Delta streamer job that takes the data in regular intervals from Kafka and then performs an upsert on the offline storage, which are Parquet files with additional Hoodie metadata. So that gives us not only a complete history, because we, instead of rewriting the entire features all the time, feature tables all the time, or feature groups all the time, we perform upserts using Hoodie that gives us a nice timeline of commits, which rows have been updated in which commit. So you can potentially also roll back your offline feature store, or if you want to perform debugging, if there has been a bad batch, you might want to be able to read up the bad batch and see what went wrong at that point in time. It's what we call point-in-time queries. And then the other part of the pipeline that's consuming from the same Kafka cluster is the upsert service for the online feature store. And that one just takes records from Kafka, decodes them, and then performs the upsert on the online database on HopsDB. And the nice thing is that we're keeping all the metadata. So for example, schemas, also the commits for the offline feature store in our in-memory database, so that that ensures consistency in a sense, right? So we can make sure that at all steps of the pipeline, we're using the same schema, the same rules to decode the data, and so on, which is very beneficial to set up the entire pipeline. And basically, also the user only sees his client API from there. Yeah. And then the question is, of course, how do you use it? I've hinted at it. It's mostly data frames. So you have your data frame that you read up from, let's say, a streaming source, Kafka. You deserialize it, perform some pre-data wrangling, let's say, and then you have window aggregations to compute features, for example, if you want to compute, over credit card transactions, you compute the average amount of credit card transactions, which gives you a streaming data frame. And then the only thing you have to do is you get a reference to a feature group from the feature store, and then you insert it as a stream to the feature store. And this will launch a Spark streaming query in this case, which will block the application and keep it running. Right, you can set up additional things like checkpointing and so on. And what we're trying to do is trying to be pluggable. So that means this actually, as long as there's connectivity between your Spark cluster and Hopsworks itself, you don't have to run this within Hopsworks. You can bring your own cluster, Spark cluster. And the only thing, if you have existing pipelines, for example, is adding those 2 lines in the end, right? If you have all the feature definitions already or the aggregation logic in a job, you only need to add 2 lines. You have to create the feature group object first, but to populate some metadata, providing the primary key and so on. But after that, it's just getting a reference to it and ingesting the data from there on. And it works the same from a Python kernel using pandas, and with Flink, it's a bit different, but essentially it's the same code that you need to write. So it's very simple, very straightforward, and you can reuse your existing pipelines. You don't need to re-engineer everything for this. So what are the 3 key takeaways of this? First of all, you should have all the data live in one central place, right, for your machine learning applications to make sure it's consistent, and also to avoid this spaghetti pipelines. Let's say you want to be able to reuse the features, you want to make the features discoverable, and you do that using the metadata. For example, data scientists using statistics to know which features might be helpful for a new model. And then the second one is, which I think often is misunderstood when they hear about feature stores. Feature store is a big infrastructure element in your stack. A feature store that you can pip install, for example, will not satisfy all those requirements that or you won't be able to serve all the business use cases that I've shown, like all the evolutions of ML applications. So you can have client libraries that you pip install, right? That's the goal. But an actual full feature store, the technical requirements, make the need for infrastructure. So we try to make it as easy as possible to get started with Hopsworks. But in general, it's not something you pip install and have a full-blown online feature store, right? And then the other thing that we learned is, even though the architecture itself is nothing super novel, but it scales very well. All the bits and pieces along the pipeline, we can scale independently. We have an upsert service that's stateless, so we can launch multiple instances of it on Kubernetes if we want. We have Kafka that we can scale, and then Spark as the ingestion engine, or Pandas. Pandas limited scalability, but yeah, with Spark we can scale that as well. And also it avoids a common mistake that we've seen in earlier iterations, is that if you have a data engineer writing directly from Spark to, say, your operational ML database from where you serve feature vectors, it is quite easy to overload such a database. So by having Kafka in between, it's a good infrastructural pattern. You basically decouple the ingestion pipeline from the actual storage in order to avoid drowning the servings or the serving applications by overloading the database with the writes, exactly, right? And then our CEO usually says, don't just talk, but also measure. So of course, we measured how fast is it actually and how much throughput and can we get with this setup. So in general, data is being written in batches once it's leaving Kafka. So for P95, for example, for a batch of 1,000 rows, it's below 200 milliseconds. So as soon as the data is in Kafka, it takes around, or like once it's taken out of Kafka, it takes 200 milliseconds to commit a feature vector of 11 features, or roughly 1 kilobyte, sorry. And the throughput, we can write around 120,000 rows with just one instance of our like upsert service, right? So we can just add multiple of these to scale it up. Of course, if you write larger vectors, the throughput is going down. But as I said, the throughput can be scaled by adding more of the services. In order to reduce the latency of writing, you could reduce the batch size as well. But of course, that will hurt throughput a little bit. So you need to find a balance between throughput and the batch size for latency. So, which is all configurable at some level. So yes, that concludes it pretty much for this talk.
Great, thank you very much, Moritz. Yeah, round of applause. Cool. For those of you who are joining us online, what we'll do is we'll do Q&A in the room, and if you post stuff in the chat, I'll come back and have a look at it in a second, and then we'll go to some of the online questions too. So yeah, open to Q&A. If people have questions, just stick a hand up and I'll come around with the mic. I'm going to ask one of my own before we get going quickly while I'm still here. So you didn't particularly talk about like the potential for reuse in a feature store. So like, and by that I mean kind of saving time on, the data engineering aspect, right? If I've got to manipulate stuff and create features that actually could be totally reused by, I mean, a small company is not going to be an issue, but at a large company, you might have hundreds of data scientists, and they might all be doing the same data engineering over and over, and you can kind of reuse it. Do you see that a lot with the
Yes, definitely. That's one of the main arguments for reducing the spaghetti pipelines into one pipeline into the feature store. Because as I said, I mean, I showed these business services, but you can think of them also in terms of business units, which are, each of them might have their own data science department doing their own ML pipelines. if they all read from the same feature store, they can see what the others have populated, basically, what kind of feature groups, and can reuse them. And then that's what I said with the metadata is the important part. You want to try to have as much metadata as possible around it in order to explain to potential users of your feature what is this feature about, how maybe has it, or there might be requirements on how to use it. For example, is it only valid for a certain market? So you might want to be able to tag it with additional metadata. You might want to be able to tag it, is this sensitive data that should not be accessible to certain people? And we've been talking about feature store as a whole, but for example, within Hopsworks, we have an abstraction of projects, and actually every project has its own feature store, so that you can isolate environments and features from teams also. So for example, if you have one team working on sensitive data, you might keep that in one project, and then have another team that can't access that, or they can have only read access but not write access to those features in that feature store.
Great, thank you. Questions? Oh, don't be shy, everyone. There we go. Yeah, go on down here.
Hi. So you hit some sexy keywords like scalable, stateless upsert service. You hit that on one of the slides, and I think that was somehow linked to HopsDB, which is I think there was some talk about some mention of RonDB as well.
Yeah. So
and you were saying that you provided those performance graphs that have two instances of the HopsDB service or something. Is that right?
Sorry, again?
So the performance graphs that you showed, you said that those P95 figures were for two instances of
the right service, yes.
Yeah. So is that scalability managed by yourself? So you're actually setting up and tearing down your own instances in real time if you have, for example, very dynamic or very volatile loads? Or is there some kind of managed RonDB or HopsDB service that you can have, a bit like Dynamo or something, or Mongo Atlas now, I think?
Yeah. So HopsDB and RonDB, just to give a bit of context, RonDB is the founder, Mikkel Ronström, or not founder, but the inventor of the database, Mikkel Ronström. That's RonDB. It's the open source database, and then what we use inside the platform is HopsDB, and we manage the whole database as a whole for you in the cloud. We launched the instances within your cloud account, basically through a cross-account role, similar to how other vendors do it, Databricks, for example. So the database itself is managed by us there, and it scales by adding more data nodes, taking data nodes away, basically. And also you can have, for example, MySQL nodes to provide a SQL interface also to the feature store or to the database. Also those you can add and remove as you go. You can do that using Terraform or through a dashboard, basically. And then the upsert service at the moment, we deploy them statically. So we deploy one or two of them, but we can always add more of them. But at the moment, it's a manual process. However, the plan is, the way we designed it is that, it's a container that's going to be on Kubernetes, and then depending on the load, we basically taking the waiting time in Kafka. So to see how long does the queue get, basically we want to scale up and down depending on that. So for the future, that's the plan, yes. But at the moment, it's still a manual process. Cool.
And that'll eventually be like a Vivo, where I can just make a call to you and say, for some reason, someone's hitting me with a ton of traffic, or my transaction count's gone through the roof because I'm getting attacked by Moscow or something. And I want to, it's happened recently to a company. done. And I want to, so if adding those is going to take like minutes or tens of minutes maybe, whereas I want to be able to go like within 10 seconds, my transaction, I want to be able to fulfill that transaction, that new transaction demand. Will that be eventually possible with Hopsworks?
Yeah, I think so. Yes, the way we set it up, let's say the base ground for it is in place. Actually, RunDB is a battle-proof database. It's coming from MySQL NDB cluster. It's used in a lot of DNS lookup services in telco mostly. So it has what we call a LATS database. It's low latency, high availability, throughput, and scalable storage. So the database itself has all these properties, and we manage it in the cloud. So so far it's been requiring some database administrators to do this, but we brought it to the cloud to manage it for our customers.
Cool. So for everyone online there, you're going to get the question after the answer, which was just about how immediately scalable is the Hopsworks service and the database underneath it. So that's what Moritz was just answering. Any other questions in the room? No?
No.
Everyone's feeling a little bit jaded after a long Tuesday. Okay, let's see if we've got some questions online. Okay, yeah, we've got a question here from Hamish. It says, thinking of reuse, does the metadata have any kind of unified explanation of how features have been engineered?
If you use, that's what I've been saying, like you can use bring your own compute, and then we have not so much control over what's the code that produces those features. But if you run the compute within Hopsworks, we have the metadata about which job and which execution of the job produced a certain commit of the features, and also what is the job specification of that. So the Spark job basically that ran to compute those features. But not if you run it outside of Hopsworks.
And do you have anything to make it like easily discoverable for people? So so it's all very well having all the metadata there for how to use features and their limitations and so on. But I don't know, I'm thinking about as a data scientist kind of into a new company, is there an easy way to just explore all of the data?
Yeah, there's a UI.
Okay.
There's a UI, it's like a shopping cart, basically. You can see the features which are grouped together in feature groups. They usually share the same primary key, or they come from the same source of data, the features within a group. And then you see the metadata of a feature group. You have, the schema, what's the data type in the online and offline storage for those features. You can attach data validation rules to the features. So for example, if you have an input pipeline, you can make sure that all rows qualify in a certain way. For example, there's no null values and so on. And then you can have tags. So you can also force, for example, data scientists to apply certain tags to feature groups. So for example, you might want to have everyone tag their features with who's responsible, you can see who created it, but maybe there's someone who's responsible of the sensitive data, or which market is it relevant for. So there's a lot of stuff around it.
Great, thank you. Any last questions from the room? Okay, well, thank you again, Moritz.
Thanks.
Those of you online, that was applause you heard, not just me rustling the mic. So we're going to take a 5-10 minute break, give people a chance to go to the loo, get another drink. I don't know, there's a little bit of food left if you rush. I've got a couple of other announcements, but I'll do them when we come back in a second. So take a few minutes and we'll be back in a bit. Okay, right, everyone. Hello. Brilliant. Everyone's taking their seats as I start speaking. That's fantastic. Okay, two things. The first is, if you're not aware, there's this fantastic online resource, the MLOps community. URL is literally just mlops.community, but they have a fantastic Slack in there with now like 10,000 members, and you can ask all sorts of questions, and people will, I mean, you know, we're not exactly DevOps yet, right? We're still kind of figuring out what best practices are and so on. So it's always useful to share with people. There's also, if you join that Slack, there's a London channel, so jump in there as well. I think a bunch of people in the room already chat on there. The second thing is that like this only runs when people have great things to say, and just by nature of doing your work, like everyone has something interesting to say. Even if you don't think you're a great speaker, there'll be something that you do at work that you think, oh, I'm really proud of that, right? If you've had that moment at any point in the last like several years, come speak to me and we'll get you up here at some point and you can talk. You don't have to do like a half an hour talk with slides and everything. If you just want to show a GitHub repo you wrote, that's cool too. But yeah, let me know, because I'm always looking for new speakers. And then I think that's it, right? I'm now going to pass over to Alejandro, who I actually have the pleasure of working with. He's our Director of Machine Learning Engineering at Selden. But more importantly today, he is wearing his hat as the Chief Scientist for the Institute of Ethical AI, and is here to talk to us about machine learning security best practices. And I was pestering him this morning already about Python dependencies, so I hear that's coming up in this. Cool. All right, brilliant. I'll unmute you and take it away.
Awesome. All right. Well, is that a bit too loud? Yeah? Okay, yeah, good. All right. Awesome. Well, yeah, before anything, thank you everybody for coming. I think it's been great that the MLOps community, MLOps London community has been growing. So yeah, and massive props to Ed. I think we're excited to see this grow more and more. Today, there's a very interesting topic, particularly on security in machine learning. So there's quite a lot of content. Let's dive straight into it. A little bit about myself. My name is Alejandro. I'm Engineering Director at Selden Technologies, as Ed mentioned, Chief Scientist at the Institute for Ethical AI, and Governing Council Member at Large at the ACM. So just as a heads up, Selden is an open core company that focuses on machine learning deployment and monitoring. The Institute focuses on contributing to policy and standards that ensure the responsible development, design, operation of machine learning systems, and the ACM is a body for professional computing professionals that contribute to different areas of the field. If you're interested on some of the resources in this talk, as you will see, a lot of this is very practical. We're going to be going through hands-on examples, so you can access it through the repo on ethicalml/FML security, and we will talk a little bit more about the title, but yeah, this is basically the repo. Flawed machine learning security. You will see all of the notebook examples and etc. So please, check it out. And the beauty of open source, if you don't like something, open an issue or a PR. So let's talk about the motivations. There is often a lot of context that we hear around security. The interesting thing about security is that when it comes to security in DevOps, in software, there's a lot of best practices, standards that are in place. And when we start looking about security in the area of machine learning, there is actually a lot of resources on how machine learning can be applied into security, right? Malware detection, spam detection. But the area of how security applies specifically into machine learning, the best practices of security in machine learning, there's not as much resources in that space. So what we're going to be doing today is fleshing out some of those best practices by taking a bottom-up approach of what are actually flawed best practices, right? Like what are clearly bad things that we as practitioners would do in our machine learning lifecycle that would open up for vulnerabilities. And we're going to be taking a similar approach to security in software. where we have to acknowledge that it's impossible to make a piece of software unhackable, right, or unvulnerable. But what we can do is introduce best practices to mitigate undesired outcomes to a reasonable extent. And we have to also remember that even though the solutions will be technical in nature, they will still be relying on humans and process, right? So you can't have tech without humans and process. We're going to introduce also all of this under the umbrella of MLSecOps. So DevSecOps is already picking up as a concept. This new terminology will be basically the extension of DevOps and security with machine learning infrastructure as the first-class citizen. And basically the intersection of this ML infrastructure, developer operations / automation, and security policies. And we're going to be defining that sort of best practice in the middle. The good thing about security is that we can rely on a lot of great resources that are out there. An example of this is the OWASP initiative, which is the Open Web Applications Security Project. They actually release a very useful resource every year called the OWASP Top 10. This is basically the top 10 vulnerabilities that have been identified through surveys in the developer community. And you can see things that you've heard before, right? Broken access control, people can't get access to your endpoints, cryptographic failures, injection, SQL injections, security misconfiguration, so things that you already would assume as practitioners. But we will actually come back to this as how we've been able to build an analogy from the machine learning side. So this is not a talk about specifically the core of MLOps, right? Like the actual steps of deploying machine learning models, how to take a model artifact into a fully fledged microservice, how to introduce observability. We already have great talks that have actually taken place in the MLOps meetup in London. So it's going to be a TLDR. We are going to actually take a machine learning model, train it, deploy it, but we're not going to be focusing on those steps for deploying machine learning models. We're going to be focusing actually on the security aspects of it, right? But if you're curious, there is a too-long read, which you can check there, right? Check the link. It's like a 50-minute talk about just machine learning deployment. But yeah, so this is in the concept of what we're going to be doing. We're going to be taking a machine learning model. We're going to productionize it by packaging it, deploying it as a service, and then being able to consume the requests and responses as predictions, right? Let's actually deploy a machine learning model. We're going to, of course, use the hello world of machine learning, the iris classifier. So that means that we're going to be taking our model that predicts flowers. We're going to be using a logistic regression with the data. We're going to train that model with our data set, right? We're not following best practices, not doing our cross-validation. We're just, getting 99% accuracy from the get-go. And we can see that now we have a model, right? It predicts if we give it an input, and the output is the prediction itself. Now, how would we productionize this, right? Like when it comes to using frameworks like Seldon Core or other frameworks that allow you to productionize models, what you would do is you would first actually make the model accessible as an artifact, right? And then this artifact would be run somewhere else as a runtime. So that's our first step. We're going to actually expose this as an artifact, and that's going to be dumping it as a pickle. Right, a pickle is a Python binary that is stored as a file. When we look at the insides of the pickle, we can see that this is just instructions that Python knows how to read that basically say, hey, if you want to load this binary, you have to actually use this Python module. You have to use this class inside of that module, and you have to pass these inputs, right? Pickles demystified, right? So now what we're going to be doing is we're going to be copying this binary into a Google bucket, right, into an object store that we can actually have our remote service pull and serve. And we're going to be then deploying it, right? In here, we're going to be using microservice that is going to be running in Kubernetes. We're going to be able to create it, and we can now see, in our local Kubernetes cluster that our iris classifier is running as a service. The only difference is that when we request a prediction locally and get a response, we now do it as a service, right? We send a prediction and we receive a response, which is the inference, right? So we now have a productionized machine learning model. Okay, sorted, right? We can go to the pub, right? 99% accuracy, we're done, right? Well, so now, normally this talk would go, okay, well, what about the metrics? What about the monitoring? What about the drift? But today we're gonna be talking about, what about the security? If we look at all of the things that we just did at TLDR, the data cleaning, the data training, the evaluation of the model, the deployment of the model, the serving of the model, the monitoring of the model, and then, of course, the kind of full end-to-end cycle. If we ask the question, what parts of the MLOps lifecycle are exposed to potential security vulnerabilities? It's actually quite simple. It's only the red parts of the MLOps lifecycle. Right? So as long as you have the red parts sorted, then you're good, right? So, okay, but now let's actually look at what that actually means. And the way that we want to do this is to ask a question. If we were to look at each of these parts of the machine learning model lifecycle, how could we exploit some of the vulnerabilities? Vulnerabilities when loading the model artifacts, vulnerabilities when there's unrestricted access to the model, when there is access to the dependencies, to the code vulnerabilities, to the model runtime, and to the images. So let's start with the first one, is pickles. So who here loves pickles? Nice. We all love pickles. All machine learning practitioners love pickles and hate them. We all hate pickles, right? The reality is that pickles are ubiquitous, right? They are often what you find as a 101 in regards to, hey, how do I export my model? How do I then deploy my model? And unfortunately, there is already very broadly known vulnerabilities when it comes to pickles themselves. So let's actually have a look at what that looks like, because we all know that, right? We all know that dumping a binary is bad, right? And then loading it somewhere else. But why, right? And how could you exploit this? And let's have a look at what that looks like in practice. So if you remember our binary that we dumped in the previous code, we can just load it back into memory, right? So if we do joblib.load, we now have loaded it back into our Python world. We can run a prediction, right? We're still good. We run a prediction. It works all well. But then how does pickle work, and how can we exploit it? Well, actually, when Python loads a pickle, it actually loads this reduce function to dump that binary. It says, how should I know how to load it back into memory, right? And this reduce function is what specifies what we saw above, which module, which class, and which input. And if we actually override this function, then we have control of what we want to actually dump in that pickle. In this case, we're going to actually override it with this function, which basically says, I want you to run from the module system this command. And the command is basically this obfuscated base64 of just a simple thing, which is copying your environment into a pond.txt file. Right? But you can do whatever you want, right? You can expose this, download the Kubernetes secrets, send them in an email, whatever you want, right? It's basically running any command. So we're going to actually run that, and we're going to copy it into a new bucket on our Google bucket called onSafe model, right? When we actually see what's inside of that pickle, we don't see the same thing that we saw before of scikit-learn, blah, 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 blah. We actually see that POSIX system, and we can see that env to pond.txt, right? So this is basically what we are now dumping. Irrespective of this, right? We've already overridden the class. So if you run this in the background, a data scientist would not realize the model would still kind of perform in the same way. So now we actually copy it into our Google bucket, and when we deploy it into a model on safe, we can now see that we have it running, right? Our safe model is running, we consume a prediction, our unsafe model is running, nothing wrong, right? Python was like, yeah, model, great. What do you want to do now? But if we actually look inside of the container, that pond.txt file was created, right? And to actually validate locally, if we actually check, is there any pond.txt, let's actually, remove that. Remove pond.txt, load it, head, so it actually created, right? So as soon as you load it, you actually have that already, vulnerable situation. So that's kind of in essence, some of the challenges. And as I mentioned, there are some nuances that pickles are ubiquitous, right? Like this, if you go to scikit-learn, the first thing that you see is, how do you save a model with pickle, right? Torch uses pickle for some of the internal functions, right? And then, for some of the TensorFlow Keras side, there's also, functionality that is exposed to that. So now the question is, well, how do you address this, right? Like, do I introduce some super complex, super smart way of like scanning binaries for malicious code? And the best practice is actually in any situation where you're loading code from a source, whether it's a container, a binary, whatever it is on the principle of trust or discard, right? You either trust your source or discard, right? And these security requirements are analogous to any other application that you pull in, right? Like a Docker image, etc., as I mentioned. And of course, you need to make sure that the trust is down your stream, right? Like in the CI pipelines, in your ETL pipelines, as it goes down the stream. So that's on pickles. Now let's move to the next thing. What happens if now you deploy the model and it's safe, but there's now unrestricted access to the model as a black box, right? You can access and consume the model, but without restricting the users that can access it or the amount of traffic that it can go into that model. And one of the things that is interesting in that black box type access is the concept of adversarial examples. And this is basically examples that can be created to fool a machine learning model whilst also fooling a human, right? In this case, they are very intuitive, right? In this case, it's basically the picture of a horse that a model predicts as a horse. An adversarial example, in this case, would be added noise that would be indistinguishable, but it would be predicted as a dog. This truck as an automobile, this dog as a horse, right? It's quite intuitive to see this and be like, okay, I understand how it could add that. One interesting thing is, our data science team at Ceylon actually created this framework called Alibi Detect, which has a set of adversarial detection components, which allow you to leverage some of these capabilities to identify whenever you're dealing or interacting with an adversarial example, right? So basically, this is actually leveraging, in a way, introducing what would be extra components up front, so an autoencoder that would allow you to actually generate inputs with noise that then would allow you to compare it with the predictions of the model, and based on that, being able to identify a threshold that then allows you to understand whether this is an adversarial example, whether you should discard or continue, right? So ultimately, when it comes to adversarial detection techniques, there are a lot of very interesting and cool tools that you can adopt, right? So in this case, it actually shows some data sets that are created with some adversarial noise and how you can actually identify from these data sets with a reasonably robust prediction, right? So it is quite an interesting deep dive to actually explore. However, when it comes to this concept of access to models, or access to models as black box entities where you can consume them, of course, introducing an adversarial detection component would be a solution. But similarly, more boring things like access control, role-based access control, or just basically resource-based access control would still suffice, right? Or understanding and limiting how we can do that. I'll leave questions at the end, but yeah, don't forget that one. Nice. So it's important to make sure that we actually try to leverage not just the cutting edge, right? Because if you already know that there's going to be people exploiting your APIs, you're already going to be dealing with challenges. So it's more about how do you manage those challenges down the stream. And now the question is, okay, we've assessed what are the challenges of black box model access, but also the challenges of white box model access when you actually have access to the artifact, right? And there's some really interesting research that talks about how you can actually reverse engineer, in this case, some large language models to extract training data, and in some cases even personally identifiable data. There are in some cases some models that actually take the entire training data set when they perform inference. So there are some considerations that you need to take into account, particularly when it comes to your production environments, when dealing with access to the different services and components, as opposed to just taking the approach of, okay, well, actually, these are just amalgamated, learned weights, so I don't have to care about that, right? So there's nuance, and also it's not just about always trying to take a, hardcore type security consideration, but also proportionate to the risk that you're facing, right? It's always proportionate. So now let's move to the next part. So we've talked about pickles, so access to the source where your artifacts can be created. We talked about access to the model. Now let's talk about access to the code of the model, right? And this can be coming in the form of Jupyter notebooks. This could be coming from the form of runtime, machine learning runtimes. And you may think to yourself, well, actually, how would a piece of data science code be affected by that? And you would be surprised. I mean, some of you may remember a recent issue that actually came up with the PyYAML package with the load from unsafe, which actually had a massive exploit. That was actually something that was also affecting libraries like TensorFlow, right? So it is important to make sure that within your code, not just your development code, but also your data science code, your machine learning code, you're taking some software engineering best practices and leveraging some of the many code scan technologies that are out there, right? I mean, there are some very great open source and closed source tools. An example of that would be, things like, Bandit, right? So Bandit is a tool that allows you to actually run, code scans across your specific repo. And I think, I have one example down here. Yeah, so just here. So you can see here, like if you run a check, within the code, which is currently locally, it would tell you what are the severity, the issues and the respective severity, depending on the specific code paths, right? Like, do you have any specific area that would have to be taken into consideration? And right now, to be honest, I mean, you wouldn't have an excuse to not use this, given that it's fully integrated with things like GitHub, right? Like GitHub even bothers you going like, hey, are you sure you don't want to activate code scans in your repo? And I mean, I'm sure like some of you have spam from Dependabot, receiving like 500 vulnerabilities in your repo that are unaddressed. So yeah, address them. And yeah, just kind of like a reminder that, Jupyter notebooks, if they get to a certain extent, they also are code, right? So you have to take into consideration when it comes to the areas where you are at risk at these potential areas. Okay, so now let's move to the next part, dependencies. So when it comes to dependencies, this is an interesting area, particularly with Python, right? And Python dependency management is a massive pain, right? Anyone who has maintained the package for more than a few weeks with some users would have an experience where they go, to their home on Friday, and then they come back on the Monday, and then their CI is broken. Nobody touched anything, but it's broken, right? And you check why, and it's because, the 15th level dependency didn't pin the 14th or 16th level dependency, and they updated a breaking change, so all the entire thing just, broke, right? And the challenge with that is that, yes, there are situations where you end up with a nuisance where some package updated with a breaking dependency, but there has been situations where actually there has been security vulnerabilities downstream. And that's why it's now becoming really important and a very highly discussed topic around the consideration of software supply chain, right? And supply chain risk, right? If I actually bring a new project dependency, what is my risk at the multiple levels of the dependencies, right? And actually, there's been several high-profile incidents that have, introduced malware at the low level of the supply chain that have also raised some really interesting ethical questions, but that, objectively actually raise the challenge of, how do you address these vulnerabilities? We've actually done some collaborations with projects like MLflow, where, if you have used MLflow in production, you would be familiar that in at least their previous containers, they used to kind of like install everything on the fly, right? And that's something that for many reasons, you wouldn't do it. Let alone security. I mean, just convenience or even like reliability, robustness. So some of the explorations have been on how we can use actually dependency freezing of like, leveraging tools like Conda Pack to make sure that you have like parity of environments between your local notebook and that remote runtime, right? And actually that parity of environments is a pretty challenging component. That's why when it comes to dealing with production and inference models, there is not just the ability to deal with pickles, but also leverage some of the optimized runtimes, like exporting to Onyx or PyMML that allow you to actually have like an optimized runtime with a standardized serialization format, right? And yeah, there's tons of tools that you can leverage. Things like here we can see with pipdep3 all of the dependencies, and we can see tons of dependencies from our very small installation that you saw at the very top, where we're only using scikit-learn. If you look at scikit-learn, we can see that already its first level dependencies are not pinned, right? So if SciPy pushes an upgrade, that may actually break your framework upstream. So there are some ways to approach this, right? Using pip freeze into a massive file, and then just actually keeping track of that. That sounds like a massive pain. There are better tools like Poetry. Who here knows Poetry or has used Poetry? Nice, yeah, Poetry is great. So keep using it. Which basically this allows you to generate what is a poetry.log file that basically freezes all of your environment in a much more consumable way. So, and there are other things like, safety tool, which allows you to explore what are the vulnerabilities within your dependencies. Here we can see that NumPy, there are some vulnerabilities, and also tools like piprod, which are like dependabot, right? It tells you hey, X vulnerability is very old, please update it. So yeah, there's quite a lot of tools. And just to finish, actually, before moving to the next thing, this is to the reference that actually Ed mentioned. So earlier in the day, actually, I was chatting with Ed. We ran into some challenge with Conda. He was saying hey, there's this issue with TensorFlow version. Actually, it turned out to be something else, but this just made a reminder of okay, maybe you're using Poetry. And Poetry works great, but you also need to remember that the version of Poetry that you're using matters, right? So if you're running your CI tests with Poetry 3.0 and you're running your local freeze files with Poetry 2.5, stuff's not going to go well, right? So there's nuances, and that's why we move to the last part, which is images, right? This is not a Kubernetes talk, right? Even though we could delve a little bit deeper into the infrastructure side, but when it comes to the pipeline that we used, we deployed our artifact into a microservice, right? It was running in a runtime image. And these images would also introduce benefits like reproducibility of environments, but also you would have challenges where, as I mentioned, you may have disparity of environments, right? Whatever you were running locally may be different to what is on the server. So you need to manage those dependencies, you need to manage those considerations, and you also need to manage the security aspect of that, making sure that your images are scanned. There are great tools like Trivy that you can leverage, and there are closed source tools like Sneak that we, for example, use at Selvin with every release. Do container scans, we do version scans, etc., etc. So that's basically the main sort of key components. There are some honorable mentions, of course, on the infrastructure level that we're not going to be delving into, but things like encryption for data or artifacts at rest and in transit, things like authentication and authorization, things like infrastructure hardening considerations, and these are things that we've had to really deal with when we are developing a Kubernetes application for machine learning deployment, right? So that's basically what we've had to actually really flesh out very deep into that. And if you remember at the beginning of the talk, I mentioned the OWASP top 10. The interesting thing is that these components that we just touched upon are analogous to those OWASP top 10, right? Things like broken access control, we talked about it on the black box access to the model endpoints. Cryptographic failures, we talked about that in regards to exploiting pickles. Injection as well, being able to inject malicious code, insecure design, etc., etc. So the interesting thing about this is the ability to set best practices that refer into already acknowledged and adopted industry best practices in the general software world. And one of the things that we're doing that is quite interesting is we're actually working and taking this with the Linux Foundation to standardize into what is going to be a set of security principles that are for best practice that we can start pointing practitioners, machine learning practitioners, to be able to adopt as analogous means to bring into their day-to-day development, right? These are sort of things that you don't want to deal with, right? You just want to have stuff automated in the pipelines that is just highlighting things that need to be addressed. If you want other further resources, right, we actually did a massive TLDR for all of things. So, in the resources, you will find links to talks that I've given in CI/CD, production monitoring, accelerating ML inference, which we're actually doing next week at the KubeCon, if anyone is there. And then, just more general sort of like talks. Reminder that code and resources, all of the stuff that I went through in the notebook is available in the repo. So, feel free to try it out yourself. Ethical ML/FML security. And with that, that's it. Yeah, thank you all for your time.
Brilliant. Yeah, thank you very much, Alejandro. You went through a hell of a lot there in a very short amount of time. So I'm sure a lot of people will be checking out the repo. I actually got to the bottom of that dependency issue. And the issue, for anyone who ever bumps into that same thing, if you're using MLflow, it assumes that you've Conda installed something. So even though I had a dependency of TensorFlow, which was 2.8, that's not available in Conda yet, but you can pip install it. So there was like because Conda haven't caught up and verified the package yet. So you can end up with headaches like that. So yeah, welcome to Python. Cool, let's go to questions. There was one here.
Yeah.
So you're up first, and then we'll move around.
Thanks very much. I think Alejandro really enjoyed that talk. A question that's been on my mind every time I hear about adversarial examples of black box models is are there some examples you can think of how a malicious actor could use that to negatively affect a service? Because, okay, they can fool the model, but I connect the dots for me, so what? What happens after that?
Yeah. Well, I mean, I think it's very use case specific, and for the sake of I guess sanity, I won't give the driverless car example because it's always you have a stop sign that has adversarial noise and it makes it crash, right? But in more practical terms, I think there are two main situations where it could be potentially harmful. The first one is when you can reverse engineer the model for a malicious party's benefit, whilst still ensuring that it still goes on spotted by humans, right? So in cases where you may have, let's take insurance, more simple, contexts with tabular, loan approval sort of processes, if you're able to create or identify through sort of unrestricted access to a model, reverse engineer what would be the way in which you can get an adversarial example that would get you the best score, while still making sure that when a human looks at it, they wouldn't be able to understand that it actually fooled the model. So one side is the harm that it can cause by somebody exploiting it. And I guess the second one is, potentially being able to cause harm to the machine learning system. I mean, I think that one would be a little bit harder. I wouldn't know exactly what could be the case. I think most of those would be malicious parties being able to exploit and kind of game the system. I think that's most of these.
Very quick follow-up.
Yeah.
Which is just, sorry.
So the online.
I'm a little bit behind on the literature now. How bad are black box adversarial examples versus ones that have access to the model gradients? Are people still able to produce really good adversarial examples just from input-output pairs?
Yeah, no, I mean, that's interesting. I mean, I think for that one, I would definitely point you to our data science team because they published a paper on that, so they will be able to answer that. But I think from what I presented, so this adversarial example wasn't like a drift detection model that you introduce and train. This was basically that autoencoder that was able to, create examples that when running through the model, you're able to calculate the KL loss and then use that to define a threshold. So it wasn't like a adversarial example per se, like a model that you would train and you would actually deploy it with specific weights. So, I think the actual literature is still more in the early side and is more like the sexy part of security. Most of the times when you look at challenges when you have access to the model from a black box model access, most of the times you would restrict that not through an adversarial detector, but more like role-based access control. And specifically in regards to how it compares from black box model and white box model access, I would say probably open an issue in the Alawai the Tech repo and they'll send you all the papers on that.
Cool. Any more questions? Yep, one over here.
Hi there. Thanks for the talk. I wonder if with what you described before with the Python dependency, is it not more like a build problem rather than anything else? So, for example, we are using in our company Bazel to kind of make sure all the dependency are the same for Python, which is well, works, but it's a bit painful. And I wonder if without a bit of more complexity in the build, you can actually achieve security and reproducibility in all your environment without that?
Yeah. Well, I mean, I think the way that we have been able to approach it is with just Docker images, right? Like that would allow you to ensure that the environment itself is self-contained and everything that runs is going to be consistent. The challenge is, how do you make sure that the actual Docker build is always reproducible? And that's where introducing tools like CondaPack or Poetry allow you to have both a explicit overview of what's installed that actually allows you to ask the question of what is there, but also being able to certain extent reproduce it. I mean, I think the challenge with Python is that, inside of the wheels, often you have random things that may pull from other services. So actually having like a fully reproducible environment with Python, it's quite hard. So I wouldn't be able to give you like a one-stop answer, but the way that we have been able to replicate it to an extent that is quite reasonable is with Poetry plus Docker images. And that allows for users to say, I want to deploy an artifact, so I will use that Poetry lock, load it in my environment, make sure that my artifact has the same and has parity, so that when I train my model and it's there, it's going to have as close as possible to parity that you have. So yeah, unfortunately, there's nothing out there that is like going to 100% solve that. But I think what you're doing sounds like it's quite reasonable with Bazel. Yeah.
Cool. I thought someone else had their hand up back here. Yeah.
Do you have any tips for ML on the edge? I do quite a bit of work on iOS and looking into federated learning and stuff like sending model loss over the network. And there's quite a bit of obvious issues around that. Do you have any thoughts on that?
Yeah, well, I mean, I think that delves slightly more kind of on the privacy side, which is still quite relevant to security side. But yeah, I mean, I don't think there would be specific things that I would think that wouldn't be also touching upon the reproducibility aspects, the parity of environments in the edge with other components, and as well kind of like the infrastructure, communication channel security of encryption in transit. Yeah, I mean, I wouldn't know specifically, but I mean, I think this is why I am quite keen on this initiative in general. At least from where I have been able to search, I haven't been able to find much that provides best practices, like objective best practice on security and machine learning. So I think this is something that will require practitioners, groups like this one, to work together on exploring and defining what are ways to mitigate those undesired outcomes, some that could be focused on verticals like, I don't know, federated learning or edge. But yeah, I wouldn't know exactly. Yeah.
One small question about the presentation. I saw you talk about PEEP and Poetry. Like, can you give us more argument, security-wise, from PEEP vs Poetry, or argument to migrate a project which was built using PEEP for dependency to Poetry?
Sorry, I couldn't understand. So you said about the access to the model endpoints and how to restrict them, examples of how to restrict them?
No, you talk about PEEP and Poetry for dependency management and handling security issue. I would like to know some more argument. Like, for example, if someone considering moving a project which was built using PEEP to Poetry for security reasons.
So basically, why would someone choose Poetry over PEEP?
Yes.
For security? Okay.
Yes.
Yeah, I mean, I think it was basically like showed in the example. I mean, with PEEP, you basically can pin either your first level dependencies or your first level dependencies for all the dependencies that you've installed. And that ultimately is not really a very elegant approach, and I think it's very much a workaround to try to make it work with pip. Whereas Poetry, as first feature, is to actually create a log file that allows you to actually have a dependency tree of all of the components that you're using. So, I mean, that would be primarily the benefit, is that Poetry focuses on that as a feature, whereas pip is just the package manager to install, and resolve the packages as it comes dynamically. So, I mean, I would recommend you to check it out, and yeah, it's pretty intuitive of the benefits that it brings on top. Mm-hmm.
Cool. Any final questions? Cool. Well, yeah, thank you again, Alejandro.
All right. Thank you, guys.
So yeah, thank you all for coming. Everyone online, thank you for joining and sticking it out with us. This is the bit that you lose out on by being at home. Feel free to stick around. I think we still have some drinks. All the food looks like it's gone, but network and chat to people. Bring up the topics and come and corner some of the speakers as well. So yeah, thanks again, Moritz, and thank you, Alejandro. And I will see you all on the 19th of July. So don't book your holiday until the 20th. Right, go away then, or go away in August. Cool, thanks.